All right, let's try this. Let's review some terminology first, okay, guys? I know it's been a while. Um, when I'm talking about algebraic expressions, does anybody know the difference between expressions and algebraic equations? Anybody know the difference between equations and expressions? Just guess. Um, yeah, that's pretty close. That's pretty close. The main difference here, what I was really looking for is in algebraic equations, and we'll get back to the formal definitions, and that'll explain why you're pretty really close. Okay, equations. You have an equal sign, right? So you always have something equals something, and you have to. What's your ultimate goal here when you have an equation? Your ultimate goal, whatever the variable is, say the variable is an x, you want to have that equal something, right? Whether it's a number or a fraction, or sometimes. Sorry, guys. Whether it's a whole different expression, it could equal anything. But what you're actually doing here is you're isolating that variable. See how that variable is on one side and everything else is on the other side? So you're isolating the variable. Or another way of thinking about it is you're solving for x, right? So we use a lot of times in the directions of equations. Well, solve the equation, right? You'll see that a lot. Thing with an expression is, well, first of all, there's no equal sign, right? Makes sense. There's no equal sign, but you can't just leave something all strung along, can you? Like you would never leave the expression 4/8. You would put it in as one half, right? So what you're really doing with expressions is you're simplifying. Okay, you're simplifying expressions. You're simplifying, or a lot of times they'll give you in later in this note sheet. Um, a lot of times with simplifying, they kind of have you evaluate expressions if you're given a value, right? So a lot of times they'll say evaluate the expression, evaluate. Okay. But in all cases, you have to simplify. And simplify meanings if you can combine like terms, you got to do it. If you can reduce a fraction, you got to do it. You know, so you're always simplifying or reducing when you're working with expressions. Okay. Now, sometimes you don't know what what they really want for the expression, what the reduction is or the simplification is. Always look in the directions. Okay. Directions will tell you, hey, this is an exponent. We want it expanded, or if it's expanded, please write it as one. as an exponent. Okay, so you got to watch with expressions what they want you to do. In this case, they gave us this is an expression, by the way. This you were saying, well, it's an equation because it has an equal sign. Well, yeah, what they're telling you, what this equal sign is doing is it's telling you what this is. So yes, these two are equal, but it's really you're not solving anything at this point because there's no variable. Okay, so let's talk a little bit about this first one. I already told you that 2 to the fifth is what's called a power because it has 2 as a base. Guys, I'm going to have to take this up because I can't see my numbers. So it has 2 as the base. That's my base. And then the 5 is my exponent. Okay. What that means is the power, I'm taking that number 2 and I'm multiplying it. I have 5 2's. So I'm multiplying it by itself 5 times. And I want to make sure I didn't screw this up because I screwed it up yesterday. So 2 times 2 is 4, times 2 is 8, times 2, 16, times 2, 32. So I can simplify this to 32. All right, some more terminology here. Here I have letters. What are letters representing, or what are letters called? Variables, right? In fact, a variable, does anybody remember the definition? Unknown. Yeah, it's an unknown value. Okay, it represents a value. By the way, it doesn't always have to be a. Um, it doesn't always have to be a letter, right? It could be. I could have triangles here. I could have triangles, rectangles, and circles. Those are all symbols representing the value. If you those students that are going to go on to engineering and maybe some doctor degree or something, you're going to learn that mathematics and science they use a whole lot more than English alphabet, and it really is its own language when you get into theoretical mathematics and physics. Anyway, that's one of the hardest things, and I'm trying to teach you this terminology because a lot of times my high school teacher, none of them really told me the difference between an equation or expression. Or when we started algebra, um, that these variables just represent a value. Okay. Well, it's really kind of an abstract thought. It is an abstract thought because what we want to do is have like a standard equation or an expression that we can plug in any number and get a specific outcome. Okay. Well, in order to do that, we have to put in a symbol, most cases an X, and that's what algebra is all about. So it's not it's a really abstract thought that we expect students to just get right off the bat. Give you the definition you're supposed to do algebra, and it's not the case. Okay, it's really more than that. And a lot of teachers kind of skip over that stuff and a lot of the terminology here. It wasn't until like I went to community college that I really started understanding what all the difference was of these things in algebra. Okay, so variables represent a value that you choose, okay, or is given to you. Um, and here's another thing. There's two operations in math that's really cool. You may not think so because you're not math, but addition and multiplication are two operations that are commutative, which means I can change the order. 2 times 3 is 6. 3 times 2 is 6. 2 plus 3 is the same as 3 plus 2. It's 5. So you can change the order. It's commutative without changing the outcome. Okay? So I know this is a simple problem, but when we get into longer problems, this is really going to help. A lot of times you can actually change the order here. So I'm going to, because it's all multiplication, so I'm going to group my x's together. I got one x here, I got an x here, I got an x here, and then I've got a y here, and I got a y here. So I group my x's together and my y's together. Now, again, this is an easy problem. You probably didn't have to do that, but when you get into more difficult problems, this is really going to help you. Okay. So if I wanted to write this as a power, well, I have x's, and I have three of them. My y's, I have two of them. So I simplified this expression to this. Questions? All right. Now, B, we got to be careful. I only had multiplication in this problem, right? This one, I have multiplication and subtraction, right? Okay, so I got to be careful. I'm going to keep the parentheses here to keep them separate. I got my minus 3 out here. Now, 6n. What mathematical operation do I have between the 6 and the n? Multiplication, right? So I actually have 6 times n times 6 times n times 6 times n times 6 times n. So, by the way, do you know what that 6 is called? Coefficient. There you go. Good. Coefficient. Coefficient is a number being multiplied to a variable. So I'm going to group my 6's together. I've got 6 times 6 times 6 times 6 times n times n times n times n minus 3. Watch your PEMDAS. I got to do my parentheses first, and inside the parentheses, I have multiplication, right? So parentheses, multiplication. I can't do this anything with this 3 because it's bottom of the totem pole here. Okay. 6 times 6 times 6 times 6. Well, luckily I did this before my other class, and I know that comes out to 1296. And I have 4 n's, right? I have n, and I have 4 of them. So I have 1296 n to the 4th. Now I can put my minus 3 there. And if I take 1296 minus 3, I get 1293 n to the 3rd, or 4th, right? We good with that? Everybody like it? I'm going to go on. Wow, you guys are gullible. So gullible, man. You know why? Because you haven't done math for 2 months. Can I take 1296 n to the 4th and minus 3? No. Why, Sierra? Correct. They're unlike terms, right? If this was 3n to the 4th, I could do it. This is a no-no. Please don't do that like I did. This is my answer. This is simplified. I cannot go any farther. I cannot combine 1296 n to the 4th with and subtract 3 from it. They're unlike terms. Good. No, this is your answer. That's it. You don't even have to put anything else with it. Okay. Um, I'm sure you guys had run into this problem before where um, the whole negative sign when you're taking it to a power, taking it to an exponent, that if you include the negative sign, because all it is negative one times three, right? Now, if you include this in parentheses and then raise it to a power, you're forcing PEMDAS, okay? You're forcing to take negative 1 times 3 first and then multiply it to itself 4 times. So negative 3 times negative 3 is positive 9 times negative 3, negative 27, times negative 3 is a positive 81. Here, we're telling you we're forcing PEMDAS here. Well, we're not forcing it, but PEMDAS tells us, hey, take that 3, because there's no parentheses here, right? So it's telling you take 3 to the fourth first. That's your first step. Negative 1 times 3 to the fourth, we know it's 81. Then multiply it by negative 1. Okay. See the difference? Now, it's okay for this problem. Well, it's not okay, but it's not such a big mistake because it's just a sign change. But when there's other operations or it's in the middle of a problem, it can really mess you up bad. So be careful when you have, especially when you have a negative number raised to a power. Ask yourself, hey, is that number in parentheses or is it out of parentheses? Especially when it comes to the SATs, they will put this on there. All right. And we talked about PEMDAS, so let's kind of run through these real quick. Negative 4, again, I'm going to put these out in steps because I'm a teacher. I'm sure you can do a couple of these steps, in your head. That's fine. Just be careful. Um, I'm going to put in here, let's see, I got negative 2, parentheses first, negative 2 plus 5, 3. Okay, can't do anything. I can't do anything with the parentheses. I'm simplified it. Next is exponents or radicals. So I have negative 4 plus 22 and parentheses 3 squared, 9. Okay, done with exponents. Go to multiplication and division. I have 2 times 9, right? Negative 4 plus 18. Now addition and subtraction, 14. Okay, here I have negative 5 squared plus 3. I'm going to do my parentheses first. 2 minus 6, negative 4. Okay, exponents next. Now here's that. You got to be careful. This one does not have parentheses. So I'm taking 5 squared first, which is 25, plus 3. Now this time I'm taking negative 4 squared. So negative 4 times negative 4, 16. So I have negative 25. 3 times 16, 48. Minus 25, I get 23. Okay, see, I have, whenever I have more than one term here, in fact, if you got, if it's just not a normal fraction, what I mean by a normal fraction, a number on top and a number on the bottom, put parentheses around there because that's going to help you guys not make this mistake. On these problems, you have to do the numerator first because there's two terms. 8 minus 3 is 5. 3 plus 2 is 5. Then do the division. Okay. So if I didn't put those parentheses around there, I may have done the division first, 8 divided by 3, negative 3 divided by 2 first. It's easy to do. So put those parentheses on there. That'll force you to go back to the beginning of PEMDAS. Then do your division. 5 divided by 5 is 1. Okay, I did skip, I forgot to tell you guys about, I wanted to mention something up here. If I have the number 8, is that a power? No. Why? Yeah, it's not correct connected to an exponent. So we would think that that's not a power. Is there an exponent there, though? Yes. What's the exponent?
1.
So technically, every number is a power because there's a 1 there if it's not there. But we don't go around in real life and, I would like 8 to the first power shirts, right? You don't do that. So in real life, we just call it a number. But technically, um, it is all numbers are powers, right? What is 8 to the first? 8, right? What's 8 to 0?
1. 8.
Well, 8 to the first is 8.
Oh.
And it is, it makes sense that it would be 0 because you have 0 eights, right? It's actually 1. It is 1. And I used to know why, but it's one of those things I learned and was really difficult to understand, and I never gone back to it. And I'm sure like Hoffbauer or Bruiser knows. So if you really want to know why, you can ask them or Google it. All right. It's pretty much, we're almost done, guys. Evaluate. What does it mean to evaluate? Yes. You're going, but they give you, when you're evaluating, they're going to be giving you a value. Okay. So what you're doing is you're substituting in the given value and then simplify because it's an expression, right? So I'm gonna, wherever there's an x, I'm gonna substitute in that value and then simplify. Now, even to this day, when I'm evaluating, I use parentheses. I know you got it's a pain in the butt, but wherever you have an x, put in those parentheses and leave everything else the same. So I'm going to put in my -2 for the x and then follow PEMDAS, right? Parentheses, well, there's nothing to do in these parentheses. Exponents, that's what I do next. -3. So Negative 2 times negative 2 is positive 4, right?
But X or two is a negative.
I'm sorry?
The two is a negative, the little, what is it, exponent?
It should be a positive 2. Yeah, I think that's the copy machine that screwed that up.
Um,
Okay. So negative 5 times negative 2 plus 7. And again, I'm writing every step out because for teaching purposes here. I know things get a little boring, and I know you can do a couple of steps at a time, but trust me, for review, it should write out every step. Okay, so I got no more exponents. Go to multiplication division. Negative 3 times 4, negative 12. Now I'm going to take that minus 5 times minus 2. I get a plus 10 plus 7. Negative 12 plus 10 is negative 2 plus 7 is 5. Questions?
So wait, so when we do the parentheses with the the x value, are we separating the three, we're separating it from the three? The,
Well, it is separated to begin with. Remember, this is negative 3 times x. So they're separated to begin with. So yes, I'm putting those parentheses there to force me to think that there's an operation there, and that there's an operation here. Okay, that's why I still to this day put parentheses in there because it does get confusing. Okay. I only want to talk about we talked about like terms. Be careful. Um, these are both to the first power, so you can combine those to 5x. I'm sorry, 3 minus 2 is going to be 2x. 1x. Thank you. I'm getting ahead of myself. If this was a power of 2, 3x squared, you cannot combine those. You would have to leave them, right? So it would be 3x squared minus 2x plus 15. So be careful. Watch the exponents. Terms. I want to mention something about terms. Again, this is one of those things my teachers never fully explained to me. Terms are separated by a plus or minus, by a plus or minus sign. Okay. If I have, 71 x, y, z, a, c, 4, this is all one term. There's no minus signs there, right? Or plus signs. Here, I have a plus sign. This is two terms. I just made up some numbers. This is two terms because of that plus sign there. Now, sometimes you can combine, like this one started off with four terms because they're separated by plus and minus. And we ended up combining the 3x to the first minus 2x. I got x to the first plus 15, right? So I took four terms, I simplified it to two terms. You guys understand that term? Because, like I said, even my high school teacher never fully explained that to me. And for years, I couldn't figure out how many terms an expression had. We good? Now, I can give you the homework for this or we could wait till tomorrow. Do the second part, give you the homework sheet, and you'll have tomorrow and Friday to work on your homework sheet. More than enough time to get it done before the weekend. Unless you really want homework tonight, I can give it to you.
So when do you have one? Mr.
I'm sorry, what?
When you were asking about lunch earlier?
Yeah, my schedule's changed so much. I forgot when lunch was.
Do you have the same